Section 11.4, we're going to look at circumference and arc lengths of circles. Circumference is something that you should already be familiar with. We already talked about this earlier this year, and I know you've seen it in years past. As far as arc length goes, we've talked about arc measure. Now we're going to see how arc measure relates to arc length. So just some vocab things to be aware of. Obviously, the circumference is the distance around the circle. You can think of it as the perimeter of the circle. That's another way of thinking about circumference. So, in other words, that whole entire distance there that I outlined in blue, okay, the actual distance would be the circumference. And the length of an arc is a portion of the circumference. So, in other words, if I draw in a central angle here, you'll notice that creates this arc right here, okay? The length of that arc is clearly going to be a portion of the entire circumference, okay? And so that's kind of where we're headed here with this lesson when we talk about arc length. So first of all, the circumference of a circle is found, you can have two different formulas. I always just say pick one and use that one. You can use 2 pi r, or you can use pi times diameter. Okay. Again, pick one and go, because obviously if you know the diameter, you know the radius. If you know the radius, you know the diameter. So don't memorize both formulas. It's just useless. Alright, so it says find the indicated measure. Part A here says the circumference of a circle with radius 11 meters. Okay, so circumference equals, I always like the 2 pi r formula personally. See if I can get this thing to write decent for me. 2 pi r. Okay, that's better. And so we know what our radius is. Our radius is 11, so we have 2 times pi times 11. And so we'll just say that that's 22 pi meters. And again, you could get a decimal around to the nearest hundredth or tenth or whatever, it doesn't matter. Part B says the radius of a circle, we want to find the radius of a circle whose circumference is 18 yards. So C equals 2 pi r. Excuse me. We know what C is. We know C is 18. So 18 equals 2 pi r. We got to get r by itself, so we divide both sides by 2 pi. And so the radius is roughly, let me grab a calculator here. I'm just going to use 3.14 for pi here, just because the calculator that I have specifically doesn't have a pi button on it. So 18 divided by 6.28 equals, so you should get something pretty close to 2.9 or 2.87. And again, it's a radius. The circumference was 18 yards, so the radius is 2.9 yards. Just make sure you have the right units, that's all. Alright, the dimensions of the skateboard wheel are shown below in millimeters. To the nearest meter, how far does the wheel travel when it makes 35 revolutions? Okay, to the nearest meter. So there's a couple ways of doing this. You can find your answer in terms of millimeters and then convert to meters, or you can convert everything to meters right away. Okay. The big thing is to realize that there are 1,000 millimeters in 1 meter. Okay. So you might want to note that 1 meter equals 1,000 millimeters. I apologize for the writing there. I don't know, this board's kind of acting goofy on me right now. But so anyway, it makes 35 revolutions. Okay, so really my goal here is find the circumference, because 1 revolution is just 1 circumference. Okay, so here's what I do know. I do know that the diameter is 20 plus 40, or 20 plus 20 plus 15. So that's, what is that? All of those together make 20, 40, 55 millimeters. Okay, and so what I'm going to do is I'm going to find the circumference, and then I'm going to take the circumference and I'll turn that into meters. Okay, so what we have here is C equals 2 pi r. Since my r is 55, since my diameter is 55, that means that my r is half of that. So 55 divided by 2 is going to be 27.5. Okay, so I have circumference equals 2 times 27.5 is 55 pi. millimeters. And since I want to convert that to meters now, so I have to 55 pi millimeters. If I want to convert that to meters, then what I have to do is I have to take that and divide it by 1,000. So I have 55 times 3.14 is 172 millimeters divided by 1,000 tells me that the circumference here is 0.173 meters. Okay, and now the question is, to the nearest meter, how far does it travel when it makes 35 revolutions? So now I know what one revolution is. One revolution is this. Multiply that by 35, and my final answer here is going to be, let's see here, 0.173 times 35, 6.055 meters. Okay. You guys can do part B if you want on your own, and then we'll take questions on that tomorrow in class. Same process, same idea, just solving for something different, that's all. Alright, now we're getting into arc length. This is going to probably be some new stuff here, so you're going to pay careful attention. The ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So you can set this up two different ways. You can set it up by saying, hey, arc length over the entire circumference is 2 pi r. So in other words, the portion of the circle over the whole circle equals the portion of the circle over the whole circle. Or you can say the arc length equals measure over 360 times the circumference. Either way, I'll be honest, this is primarily the one that I'll use, but it doesn't really matter. We can kind of interchange between the two. So part A here says find the arc length of AB. Okay, so depending on which way you want to do this, I'll set it up two different ways here. So arc length equals arc measure. So here's AB. The measure of arc AB is 88. So 88 over 360. In other words, what percent of the entire circle are we looking at? Well, 88 out of 360 degrees is the percentage of our circle times the entire circumference, 2 pi times radius. And so when I go through here, I have 88 divided by 360 times 4 pi. I'm going to do a little bit of legwork here. I know that 4 goes into 4 once, 4 goes into 360 90 times, and then 2 goes into this 44, 2 goes into this 45. So really in terms of pi, what we have is we have 44 over 45 pi is the arc length. And as a decimal, again, give me a second here. So I have 44 divided by 45 times 3.14, and I get 3.07. And again, the units is meters, because now we're actually finding the length. So in other words, the distance from A to B along the circle is 3.07 meters. All right. Part B here says find the measure of arc RS. Okay. Really, there's not a whole lot to do here. Well, let's just look at this. So again, you can set this up a few different ways. Okay. But here's RS, right? So, and again, don't assume that's a diameter. Some of you guys might want to assume that's a diameter. Don't assume it. They're asking you to find the measure, so I doubt it's going to be that simple. Maybe it is. We'll find out in a second here. But here's what I do know. I know that arc length equals the measure of the arc, so measure of RS, divided by 360 times 2 pi r. Okay, and it looks like here they're telling you that the radius is 12.3, and so we know the arc length is 38. So 38 is the arc length equals the measure of RS, which is what we're trying to find, divided by 360 times 2 pi times 12.3. Okay. Again, I apologize for the writing here. I don't know why the smartboard is not allowing me to write very neatly. Not that I write neatly anyways, but okay, so anyway, here we go. I'm gonna kind of solve this. I'm gonna talk you through what I'm plugging into the calculator. So I'm gonna do 38 times 360 Alright, so what I've done is I've essentially gotten rid of this 360 now. And then I gotta take that and I have to divide that by 2 times 3.14 times 12.3, and I got the measure of RS to be roughly 177 degrees. Okay, so again, it appears as though that's almost a diameter, which it clearly is, and that's why the arc measure is 177 degrees, not quite 180 though. Alright, as I look down here at part C, find the arc length of AB. So here's AB. We'll set this one up a different way. We're going to say, so we have the measure of the arc, so 97 over the entire circle is 360 equals, and then we have arc length, that's what we're trying to find, over circumference. Okay, and then from here you're going to cross multiply and solve, so you get 360x equals 97 times 8 pi. So I have 97 times 8 times 3.14, and I got roughly 2,436.64. Divide both sides by 360. And I got the arc length to be roughly 6.77 feet. 6.77 feet. Alright, example 4 says a conveyor belt for a luggage at an airport is shown below. The outer part of the belt forms a 180-degree arc at each end. For each arc, the radius is 8 feet. Approximate the distance around the belt for a coin on the outer portion. Okay, on the outer portion. So, let's see here. The radius is 8 feet. That's 8. So here's what we do know. We know from there to there is 20 feet. Okay, and then what I can do now, and I'm having a hard time seeing if this radius, well, let's just assume that this radius goes all the way out here. I can't tell if it does or not. Down here it doesn't look like it does, but so we'll just go ahead and we're going to say that that's the radius. Okay, and so now what you'll notice is this and this, if I were to pull them apart and throw them together, would create one full circle, okay, with a radius of 8. So in other words, let me get a different color here. This length plus this length is going to be the same as the circumference of a circle with a radius of 8. So those two lengths added together, I get 2 times 3.14 times 8, and I get 50.24. Okay, is those two lengths, and then obviously I also have to add in this 20 and this 20, so that's 40 more. So when I add 40 to that number, I get 90.24 feet as the distance traveled by the coin. Okay. So it's more of an application type problem involving circumference. So again, you'll see that that's the end of the notes here. So any questions you have on circumference and or arc length, obviously have them ready to go first thing tomorrow, and we'll go from there.